Hello class, we are looking at level 5 experimental activities. The first experimental activity that I would like to cover will be number 10, rotating rod, angular velocity, and acceleration. Of course, if I select on there are instructions that are in this particular link that will guide you through this experiment. But I want to do it a little bit differently for the knowledge, the level 5 knowledge basis. So under normal circumstances, I would have you follow these videos. I would have you download each angular velocity position video for the first position, the second, and the third position. And then I would have you follow these 13 videos here to actually find out what I want you to do. You'll see step 3, it says track a piece of tape that is closest to the pivot point. You want to meaningfully label the experimental video with your name and upload it to Dropbox, to the Dropbox folder, send a graphical, and then send to Excel. And then repeat the steps for the second piece of tape, and then repeat the steps for the edge of the rod. We'll end up calculating our angular velocity using the Microsoft Excel in Microsoft Excel. And we'll calculate the centripetal acceleration as well. We just end up uploading everything to Dropbox and then save that link to Moodle. But I want to give you a quicker way. I'm just going to show you real quick what I have in store for you guys. If you go to Dropbox and you go to the folder number 10, angular velocity and acceleration, you'll see the videos here, 1, 2, 3, and you'll see a template here. So this template is for the first position, the second position, and the third position. What we'll end up doing is we'll copy our data. The data will be calculated, or the data that we input, we'll have our calculations done on this side for us. So we'll have our radius calculated, our tangential velocity, our angular velocity, and if I move over, you'll see that we'll have our average angular velocity calculated, and then our resultant acceleration calculated. That's not only for 1, but it's also for 2 and 3. Now, if you notice, we have already done this work before. We did it in the unit circle, and so we actually have data collected here, and we just need to copy the appropriate one. Right here, the data is in here, but this is not the one we want because this is already producing graphs. It's another one. It's usually the CMBL. So you see we have X and Y, but we have some other ones in there. We have our velocity, we have time, and so what we want to do is we just want to copy this. So I'm going to copy that one, and I want to move that to my number 10 folder here and just paste it. So we have one file copied, and remember we actually did 2 more radii. So what I want you to do is I want you to get that information as well. So which one of these? We have the edge of the rod and we have the second piece of tape. So I'm just going to go down here to the second piece of tape. Again, you see the CMBL, so that's indicative that it's just the data. And I'm just going to copy it, and I want to go back to the folder that we had before, and I'm just going to paste it there. And then we'll do the same thing for the edge of the rod. Okay, I think I have 2 in here for some reason. So let's see which one is good. I'm going to pick the second one here. And I'm just going to copy that and go back and then paste it in number 10. Now, normally what I would have you do is something a little bit different, but let's just go ahead and go fast. So I'm going to go back to Microsoft Excel, and we should see that those 3 will populate, those extra 3. So let's go into angular velocity so we can see where we're going. This is the plan. So when we go into angular velocity, notice that we have 3, 2, and 1 position template. Let's go to number 1 here. And I'm just going to go down. Let me go back to the top of this. And I want you guys to notice what we need here. We need X, Y, we need X velocity and Y velocity. Okay, so let's go ahead and get that information. And this is for the first, so I'll just say that that's the unit circle data set. And notice that we only have B and C selected, but we have data between C and F. We have D and E. So let's unhide that. And now we have all of these data points, and we want to copy all of them and then go back to our Excel spreadsheet, our template here. And we're just going to paste those in. So you'll see that the calculations just propagate right on across, okay? We end up with 1.89 for the average angular velocity, and the resultant acceleration ends up being 0.36. So I'm going to go down here, and I just wanted to check to see that my data set actually met with my calculations. Sometimes the calculations will be a little bit lower, they'll be a little bit higher. If that is the case, you can always fill and drag down, okay? Or you can just delete. So enough of that. So now we want to go to the second position. Okay, we're going to go back and we're going to grab our second piece of tape. Well, the information from the second piece of tape. And hide it. Copy, go back, and then go back to angular velocity. I'm going to go and select on B, C, D, and E, and then just paste. And again, we have all of our information in here, just checking the bottom. And you'll see that our average angular velocity is 1.84. Notice that as we move out along the rod, the average angular velocity doesn't change much, but the resultant acceleration does. So let's look at number 3, and let's do the same thing here. Unhide. Select all of the data, copy it, then go back. Go back into our angular velocity here. And under B, C, D, and E, I am just going to paste. And you'll see that our average angular velocity is still like 1.8, and the resultant acceleration actually goes up. Just going to check the bottom here. Notice that my calculations don't go all the way down, so I'm going to select fill and then just drag down one. And this average should cover the entire piece, but it doesn't. So I'm just going to select on H. H:H will select on all of that. Nice. So we can eliminate some error. Still the same. Then the square root of J2 plus K2. So you don't see those things. They're actually behind here, so I can unhide. So you'll see the tangential acceleration, which doesn't change. That happens when, like, if you're riding a bike and then you speed up, your tangential acceleration will change, and the angular acceleration does change. So I'm just going to go ahead and hide those. And this will complete this experiment. Go to the folder on Dropbox and get your link for the folder and upload it to Moodle or save it in Moodle.